So, complex numbers. Today, you guys are going to be able to convert complex numbers to from rectangular form to polar form and vice versa. Okay, that's why complex numbers is with the whole polar coordinates concept. And then you're also going to be able to find the product and quotient of complex numbers in polar form. Okay? Now, we've dealt with complex numbers already at some point in time this year. Okay? Do you guys I think it was this year. I don't know. I might be mixing algebra 2 and this class together. Do you guys remember the powers of I? Like I squared, I to the third, I to the fourth. Did we do that this year?
That was last year.
That was last year. Okay. Did we talk about complex numbers at all? Like anything that dealt with I?
Yeah. What do you mean what came with I?
Huh?
What it turned into?
What?
What it turned into? The number?
Yeah, or like anything like doing operations or anything with complex numbers this year? Okay. Well, you definitely would have done it in algebra 2 for sure. Okay, so if you had like if you had 2 plus 3i, you guys remember conjugates? What would be the conjugate of this? It'd have been 2 minus 3i, and of course your powers of I. You know that I to the first is just I to the second is negative 1. I to the third is negative I to the fourth, not 1. Okay? These are things from algebra 2 that you hopefully have not forgotten about. Okay? So your first introduction to it was back in algebra 2. I thought we would do a little bit of something this year, but I guess we did. On the all books together. So we're going to be talking a little bit more about complex numbers. We're going to graph them now. That's something that we didn't do in algebra 2. And you're also going to convert them to polar form and also do some operations with them, okay? More complex operations. Because you guys have done stuff, you guys did stuff like this back in algebra 2. You guys did stuff like you multiplied that. You guys remember how to multiply this? How do you multiply this? FOIL, so it would be 2 minus 4i plus 3i minus 6i squared. You would combine like terms to get a 2 minus I, and then this would turn into a negative 1, which makes a positive 6, so your final answer would be I minus 8 or 8 minus I. You guys did that back in algebra 2. We're going to be doing more complex operations with complex numbers. Okay? So first, every complex number is set up in this format, A plus BI, where A represents your real part, B represents your imaginary part because it's attached to the I. And do not forget, I is basically the square root of negative 1. That's where I originated from. You couldn't take the square root of a negative number, so I was put in this place. Okay? So every complex number is set up in this part. And yes, you can have 0 as your real part, and you could also have 0 as your imaginary part. Okay? So before, on the other side, like when I did this, what would be your real part? And your imaginary? Okay, you could also have something like this. This is also a complex number. What's your real part? 0, because there's nothing there to represent it, and then your imaginary part would be negative 4. Okay? Even something like 4 can be considered a complex number because what's your real part? 4, and your imaginary is 0. Okay? Because 0 times anything is 0. Okay? So that should be just a refresher. Now, how to graph it is graphed on an argand plane, aka a complex plane. And instead of having an x and y axis, you have a real axis, which is your horizontal, and you have an imaginary axis, which is your vertical. And it's pretty simple, okay? Whatever your real part is, that's how far over you go, either to the left or to the right if it's positive or negative. And then your imaginary, you either go up or down. So if it's a positive imaginary number, you go up. If it's a negative imaginary number, you go down, okay? So this right here could be an example of 2 plus 3i, where we've gone over 2 units and we've gone up 3i units. Yes, I is located on your vertical axis because that is the imaginary part. Okay? Pretty simple. You just got to remember. The horizontal axis is real, vertical axis is imaginary. Now, absolute value bars around a complex number is the distance from zero in a complex plane. That should look awfully familiar. Mm-hmm. Yeah, the same exact thing when you were doing what? Huh? It looks like magnitude from vectors. It also looks like polar to rectangle trying to find the R. And you also saw it a long time ago, back in your geometry days, in triangles. What was it called? The first time you ever saw the square root of a squared plus b squared.
Oh, Pythagorean theorem.
Pythagorean theorem, okay?
Oh, wow.
So yes, no matter the distance between 2 points, one of them being 0 and the other one being the point you're looking for, that is Pythagorean theorem. Everything forms a right triangle, okay? So whenever you see something like this, where it's the absolute value of z, z is you know how like r equals basically is a polar form. Z equals is kind of like the set of 4 complex number, okay? So when you see z equals, we're dealing with a complex number, okay? So what we're going to do is we're going to graph each of the numbers in the complex plane and find its absolute value. So 4 plus 3i. How would I graph that? Over 4 on your real axis of 3 on your imaginary, and there it is. There is z. 4 plus 3i. And then to find its absolute value, well, that's nothing but the square root of a squared, which is 4 squared, so 16, plus b squared. What's b?
3i.
Careful.
3i. I mean,
I squared. What's the answer?
No, it's just 3. It's just the number, not the I. Because think about it, when you put 3i and you square, you're going to get a 9i squared, and then you'll think negative. You don't want to do that. It's just the actual number itself. So that would be 9. 16 plus 9 is? Square root of 25 is? So the distance from here to here is 5 units. Okay? What you guys do B. So, if I start from the origin, it started 0, 0. To graph -2 minus I have to go which way? Left 2 and then down 1. Yes, there is z, and then on top of that, the absolute value should have been square root of 5, because you do -2 squared, and whenever you square negative, you get a what? Thank you. At no point in time should you ever have a negative underneath the square root when you're doing any version of Pythagorean theorem, whether it's to find the absolute value of a complex number, whether it's to find magnitude, whether it's to find r, when you're doing polar coordinates, okay? Questions? So, the same trig ratios that were used to find x and y can be applied to represent the values of a and b, okay? Just like before, cosine theta equals, back when we were doing triangles and unit circle, it was x over r. Well, we don't have an x value because we're dealing with complex numbers. We have an a value. And instead of having a y, we have a b value. But still, a is r cosine theta, and b is r sine theta. Okay, so those have not changed. It's still the same setup. So instead of x's and y's, we have a's and b's. That shouldn't be too confusing, though, right? All right. So the polar form, also known as the trigonometric form of a complex number, z equals a plus bi, can be written in either of these two forms. The first way is r cosine theta plus r sine theta I, or you could write it with the r factored out. Either one would be acceptable. Okay?
Isn't that the same thing we were doing?
Mm-hmm. That's why they're all in the same unit together. Okay? They involve the same set of formulas. But this right here is the polar form, also known as the trigonometric form for your complex numbers. Okay? So R represents the absolute value or the modulus. That's another word for the R when you're going from a complex form to polar form. Theta is called the argument, and theta is found the same way that we found it before. Who remembers how we found theta just last week? Of inverse of tangent. And we did y over x, but this time we're going to be doing b over a. And that actually looks, we've done b over a with tangent inverse before, I just can't remember where. Somewhere recently. So it all blends in together, guys. It really does. Okay? So if they ever ask you to find the modulus, they're talking about R. So do not let that terminology trip you up or anything like that. So we're going to express each complex number in polar form. Okay? So we basically have to represent this like so. R cosine theta plus R sine theta. Okay? Only thing is that we have A plus BI. How are we going to find R? How are we going to find theta? How are we going to find R, guys?
B over A.
Cosine of
Say again? Okay? Just like we did before, right? Except instead of A's and B's, they were X's and Y's, right? So we have A squared. What's A squared? 36. What's B squared? And 64 plus 36 is, what's the square root of 100? 10. So R is 10. Hopefully the speed I'm going isn't throwing anybody off. This should look familiar. Okay? Instead of X and Y, we got A's and B's. Theta is found by doing the tangent inverse of B over A. 8 over negative 6. Somebody type that in for me, please. Gets me a value. Alright, so we want to make sure that we're in radian mode. And what was the theta?
Negative 0.927.
Negative 0.927. Now, be careful. Same rules apply when you were finding theta with your polar coordinates. You gotta do what? You gotta add pi. You gotta add technically 180 because what quadrant are we in? Quadrant 2. So in quadrant 2 you add 180, but since we're in radian mode, you're gonna add pi. So go ahead and add a pi to that value to get 2.21. Awesome. So our complex number in polar form is going to be R cosine theta plus R sine theta I. And that's our answer. Yep.
Do we have, so we don't have the answer, finish of express simplify?
Mm-mm.
Basically, you're creating the equation. You're basically creating the equation.
I is always with sign, because it's always with the B. And oh, wait, hold on. What you asked me?
You're just creating the equation.
No, someone, maybe it was you then. Yes, sorry. Yes, you do. What is that? What is 10 cosine 22.21? Negative 5.97. And what is it when you do sine? 0.03? Awesome. Okay. Let's recap just real quick with theta. When it's in the first quadrant,
Leave it alone.
you leave it alone.
Second, third,
Add 180.
180 action.
Or pop.
And the fourth, you add 360 over.
Second and third, you add pi or 180, and the fourth is what?
360 or 2 pi.
Add 360 or 2 pi. Okay, so definitely want to double check to see exactly what quadrant that's in. So if A is negative and B is positive, you are looking straight into the second quadrant, okay? Questions? Still very, it's like almost splitting image, right?
Yeah.
It's just a matter of formatting. I want you guys to look at these two. I want you to do these two on your own. Hopefully you didn't use up all that space down at the bottom.
No, I
To do
assumed
this?
you had more space, more answers. You didn't.
Alright, before we look at B and C, I just want to clarify something. Alright, I wanted to follow up behind this last little bit right here. When we found these this answer right here, the answer in orange is actually the complex number in rectangular form, not polar. Polar does include the sines and cosines. So go ahead and make a note that this is the rectangular form of the complex number.
So polar is with the cosine sign perpendicular.
Yes.
Okay.
And then the actual answer to these is the purple with the sines and cosines. This is actually the polar form, okay? So you don't have to, erase that, just make a note, okay? So when you actually multiply, actually do it through, that's the rectangular form, and then with the sines and cosines is the polar form. Rectangular. Yes, Cartesian means rectangle, so I'm asking for the Cartesian coordinates and then looking for the rectangular one. Okay?
So basically what we did to find the yellow rectangular form, we were already in rectangular form? Because we got like basically the same answer. Oh, no, yeah, basically the same answer.
I mean, technically they are, they're just in their respective domains. So once you find that polar form, to go to rectangular is simple. You just, So for B, what was your R value?
Right. R was 2.
Radical 19? Very good. You should have done 16 plus 3 to give the square root of 19. And then theta, you should have done the tangent inverse of square root of 3 over 4, and you got what before you did any?
0.409.
Point what?
409. 409.
I said 4 over 9. Okay, so 0.409. Do you have to add anything to it? No, because it was in the first quadrant. So the polar form should have been the square root of 19 cosine 0.409 plus square root of 19 sine 0.409. Yes? Awesome. And then for the last one, what was your R?
2 radical 2.
It would have been what?
Right.
Which simplifies down to what?
2 radical 2.
2 radical 2.
Oh yeah, because we're doing that.
You could have done decimal. What you for the decimal? 2.83. Awesome. Okay. If you do leave in the radical, please make sure you simplify. You could also use the decimal. What you guys get for theta?
3.93.
That's after adding.
So this was after adding what? Pi. Okay. So when you did the inverse of negative 2 over 2. 0.785. Now hold real quick. Negative 2 over 2 is what? 1. Where on the unit circle is tangent 1? It would be in the third quadrant. 5 pi over 4. So when you add a pi, or 10 pi over 4. And also in the first quadrant, but since our point's in the third, we wouldn't use that one. Trying to think, what am I doing? I'm writing it in polar form. So it's going to be 2 root 2, or 2.83,
Cosine 3.8.
plus
2 root 2. Cosine.
sine.
3.93.
Simple, yes? If you did not leave with the radical? Wait. With the 8, you want to make sure you simplify. Okay, make sure you simplify all your radicals. Now we're going to graph it. You can take a complex number written in polar form and convert it to rectangular form by evaluating. Okay? So we're going to graph this particular equation. right? It's in the form of r comma theta, yes? Now looking at this problem, you already know what r is. R is 3 because it's in the form of r cosine theta plus I sine theta. And theta is what? Pi over 6. So when you graph it, I need to be on what ring?
3.
The third ring, and I need to be at what angle?
6.
So pi over 6 is here, and I need to be on 1, 2, 3 rings. There it is.
That's it.
That's it. That's how you graph it.
Nothing else.
No, you just have to make sure you pull out the right R and the right
You get special later.
theta. No, that's pretty much as complex as it goes.
Alright.
And now to actually go in rectangular form is we actually evaluate, which we've been doing already before. Now pi over 6, that's on your unit circle.
Yep.
Okay, any value that's on your unit circle. Any value that is on your unit circle, my video watchers, I expect to see some unit circle exact values. So what is the cosine of pi over 6? Square root 3 over 2. What is the sine of pi over 6? 1/2. So this is technically 1/2 I. What do you think you're going to do at this point? Distribute. 3 root 3 over 2 plus 3 over 2 I. That is
3 root 3.
that is your rectangular form.
So you said every time we gotta do this, you gotta.
I'm expecting to see unit circle, yes, because you cannot forget your unit circle values.
What if we did the calculator? How many?
I think you'd be more mad if you did the calculator because you would lose some points.
Ah, got him.
So, if it's a unit circle value, I better see some root 3s, some root 2s, 1/2, things like that. Okay? I want you guys to do these two on your own.
Really.
Like you do have to write down the examples because they're not on your paper, but the grid, the polar grid is there.
Samson,
Yes.
there's something wrong with you. Why are you so weird?
Here we go. What was the point that you plotted?
5. 3 pi over 4.
So I need to be on the 5th ring at 3 pi over 4, which is right here. So 1, 2, 3, 4, 5.
Do that.
So there it was. And then you had to convert.
Do some math. Yeah.
What's the cosine of 3 pi over 4?
Negative.
Negative root 2 over 2. And sine of 3 pi over 4? So when you distribute, you should have had a negative 5 root 2 over 2
Plus a 5 root 2 over 2. With the I.
with the I. Okay, and the I will go in between the 5 and the radical. Okay? What about the other one? What was the point?
4. 5 power 2.
Pretty simple. So 5 power 3 is here.
4 quadrant.
4th quadrant, 4th ring. And then
Do your magic, right? So what's
1/2.
Negative.
this one's 1/2.
I mean, 1/2, yeah.
Positive, and this one is.
Negative.
So when you distribute, what's half of 4? 2. And when you distribute over here,
8 becomes a
Negative 2I.
questions.
Wait, question for you. Why did you write that?
Because I messed up. It should not be a point. There should be a negative sign
Plus
there.
negative.
Please don't plus negative. Okay? Questions? Last bit. When you are doing the product and the quotients, okay? It is pretty simple.
That's so much.
It does look like a lot, but I'll give you guys a second to, is it already written down?
Yes.
Oh, perfect. Okay, so you get into two complex numbers, okay? One, if you look at, there's a z sub 1, so you, of course you have r sub 1, cosine theta sub 1, I sine theta sub 1, and the same thing with the second one. You have two complex numbers. Product means what? Multiplication. So you're literally multiplying these two complex numbers together. When you do that, you multiply your r's together, and you add your thetas. Okay?
Right.
And it's pretty simple. It's still in the same format of r cosine theta plus I sine theta.
Alright, can I read right now?
Okay?
So you just
The thetas would be your angles. Like, so in this case, it would be your 5 power 3 and then your power 6. Division, quotient, dividing. You you divide your r's, okay, the first over the second, and then you subtract your thetas, okay? So think about it. Multiplication goes with addition, division goes with subtraction, okay? So if you're trying to find the product of these two in polar form, you're going to multiply them. So you're going to do 2 times 4, and then you're going to do what to your thetas? You're going to add them.
5 power 3 plus power 6 plus I sine 5 power 3 plus power 6.
Okay, now I'm just writing this out so you guys can see it. Okay?
Question.
Yep.
When we add the degrees, we're gonna have the same denominator, right?
Uh-huh.
So, are you looking?
So 2 times 4 is a cosine. You do need to add these, so you need a common denominator, which would be what? 6. So this would need to be 10 pi over 6, right? So when you add them together, what do you get? 11 pi over 6. That is 330. And it's the same over here. So it's going to be 11 pi over 6. So there it is in polar form. Remember, polar has the sines and the cosines with it.
What would it look like if we had R?
Huh? Well, the R1, R2 are right here. Like this is the R1 and this is the R2 because those are the two complex numbers that are being multiplied. Mhm. And this is the theta 1, theta 2. To go to rectangular, this is the one where you actually do it out. What's the cosine of 11 pi over 6? Radical 3 over 2. What's the sine?
Negative 1/2.
Negative 1/2 with the I. And then you distribute. When you distribute the 8 through, you'll end up with 4 root 3 and then minus 4i.
Do we do minus 1/2 I or just minus I?
Well, at this like intermediate point, if you did I 1/2, as long as the final answer has the number before the I, then we're good. Okay? Pretty simple, right? It's just to follow the formula. So when you're multiplying, you multiply your r's, add your thetas. When you're dividing, you divide your r's, subtract your thetas. Okay?
On the test, would we begin with that or?
I haven't decided quite yet. I'll let you know. I will let you know.
I hope so.
Okay? It's simple. It's the same setup for everything. It's the same setup.
I hope they heard all that.
You're doing this one.
Yeah.
Below. The quotient. So we divide. What goes on top? 3. So that means 4 is on the bottom. What do you do to your thetas? Subtract them for both sine and cosine. When you subtract them, you get a negative pi over 2. So you'll have 3/4 cosine negative pi over 2 plus I sine negative pi over 2. I'm going to put parentheses in there to make it a little better.
So that's the polar form.
This is the polar form. So now to get it to rectangular, you actually do it out.
Distribute.
0.
What is the sign of negative pi over 2? 0.
That's very simple.
And then, the cosine of negative pi over 2 is 0. What's the sign of negative pi over 2?
Negative 1.
So this is a negative I. So when you distribute, you basically have 0 minus 3/4 I, which is the same thing as just saying negative 3/4 I. You put the 0, that's fine. Not going to count off.
Negative 3.
Or you say negative 3/4 I. You can say negative 3 I over 4 too.
What's the thing where it says where Z sub 2 and R sub 2 is not equal
Ah, that little bit.
to divisions?
If it says Z sub 2 and R sub 2 do not equal 0, why?
That would make it everything 0.
Now we'll make everything 0 and make everything undefined because you cannot have 0 in the
Oh,
denominator.
yeah.
So it's basically like a domain.